A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth.
Far beyond the orbit of Neptune, in the dark reaches where our sun's light barely lingers, something colossal has emerged from interstellar space and entered the gravitational embrace of our solar system. This is not just another wandering comet or icy fragment, nor a minor rock that could be brushed aside as another curiosity. Astronomers have identified a gigantic object, a body so immense that its very presence defies expectations. And what has unsettled the scientific community most is the trajectory it has chosen. Rather than wandering aimlessly, the object appears to be homing in on the path of a well-known interstellar visitor, 3I-ATLAS.
Astronomers are continuing to track a newly spotted object, likely a comet, from outside our solar system.
For the first time, it seems as though two strangers from the deep void beyond our solar system are on course to cross paths within our celestial neighborhood, and the implications of this rendezvous are both exhilarating and deeply mysterious. Before we start, smash the like and subscribe buttons for more updates. The detection came from a cluster of powerful telescopes scanning the distant boundaries of the solar system. Sensitive instruments picked up a faint, moving point of light that refused to behave like any comet or asteroid cataloged before. Its brightness fluctuated, not from the familiar sublimation of frozen gases, but from something more complex, as though the surface was reflecting light in uneven, jagged patterns. Early estimates placed its size at tens, perhaps even hundreds of kilometers in diameter, making it far larger than the majority of interstellar objects previously recorded. The sheer scale of it is enough to draw comparisons with planetary moons, and in the cold emptiness it traverses, that makes it a veritable giant among wanderers. The object's orbit was reconstructed with painstaking care, each data point fed into simulation models that mapped its incoming trajectory. What emerged stunned the teams reviewing the information. Instead of a random entry into the solar system, the path was deliberate, if such a word could ever be applied to a celestial body. It was threading its way toward the projected position of 3I-ATLAS, the third confirmed interstellar object to cross our region of space. The odds of such a coincidence are staggeringly low, leading to an avalanche of speculation. Was this an accidental alignment, a quirk of galactic dynamics, or was there something deeper, something connecting these two interstellar migrants? To appreciate the weight of this event, it helps to recall what 3I-ATLAS represents. When it was first observed, 3I-ATLAS joined the short but prestigious list of confirmed interstellar objects, alongside 1I/Oumuamua and 2I/Borisov. These rare bodies are thought to be fragments or remnants ejected from distant star systems, relics of formation processes that mirror or diverge from our own solar origins. Each is a message in a bottle from another corner of the galaxy, carrying chemical, structural, and dynamical secrets we could never access otherwise. And now, with this massive newcomer targeting the very orbit of 3I-ATLAS, the scientific value has multiplied. We are no longer watching a lone emissary drift by, but witnessing the potential intersection of two cosmic travelers with shared origins, or perhaps entwined destinies. The scale of this new object demands rethinking the limits of what interstellar wanderers can be. Most models predict that interstellar visitors would be small, ejected debris from chaotic planetary systems. A planetesimal here, a frozen shard there, remnants flung out by gravitational encounters with giant planets or collisions in young systems. Yet the detection of something so massive hints at a different mechanism. Perhaps we are seeing the displaced remains of a shattered dwarf planet or the fractured limb of a body torn from a system's outer disk. Its sheer mass suggests that it endured the violence of ejection without disintegration. A survivor cast into the endless galactic sea. If its destination is indeed aligned with 3I-ATLAS, a flurry of questions arises about their relationship. Did they originate from the same star system, hurled out in the same era of dynamical instability? Could they even be fragments of the same parent body, now converging again after eons of separation? The galaxy is vast, and yet here within our solar system, two such objects may be preparing for a cosmic encounter. The mathematics of such a scenario borders on the improbable, which is why some have whispered about less conventional possibilities. The object's path looks less like a chaotic tumble and more like a guided journey, as though drawn by an unseen tether linking it to 3I-ATLAS. Even if we strip away such speculative notions, the scientific feast is undeniable. A colossal interstellar object converging with a smaller, previously known interstellar visitor offers an unparalleled laboratory for study. Chemical analysis through spectroscopy can reveal whether they share elemental compositions, hinting at common birthplaces or divergent histories. Observations of their interactions, whether gravitational nudges, fragmentation, or nothing at all, could reveal insights about the mechanics of interstellar debris when two bodies from distant systems cross paths. The event is not merely a celestial curiosity. It is a portal into processes that have shaped planetary systems for billions of years. The broader implications extend to our understanding of how matter moves between stars. Interstellar objects are the seeds of cosmic exchange, potentially carrying organic molecules, frozen volatiles, or even the building blocks of prebiotic chemistry across light years. If two such bodies converge in our system, it raises the possibility that this kind of interaction is more common in galactic space than we once thought. Entire families of objects might travel together, born of catastrophic events in alien systems, and these families could scatter across the Milky Way, seeding and reshaping regions as they drift. The arrival of this gigantic object could be the first clue that the galaxy is crisscrossed by such invisible caravans. The astronomical community has mobilized rapidly, with observatories across the world training their instruments on the object. Radio telescopes scan for unusual emissions, while optical and infrared arrays dissect the light it reflects. Space agencies are already whispering about the feasibility of launching fast intercept missions, though the logistical challenges are daunting. Unlike asteroids or comets bound to our sun, these objects move on trajectories that demand incredible speeds to reach. Yet the lure of studying not one but two interstellar wanderers in proximity is strong enough to galvanize serious discussions about engineering feats once dismissed as impractical. For now, humanity is confined to watching, calculating, and speculating. The object grows brighter as it inches closer, its immense bulk now undeniable even in amateur telescopes. Its surface betrays no tail of gas or dust, suggesting a composition unlike the icy comets that stream inward from the Oort cloud. Instead, it gleams with a cold, hard reflection, perhaps rocky, perhaps metallic, perhaps something else entirely. Each night brings new data points, refining its trajectory, confirming again and again that it is locked on a course toward the region 3I-ATLAS will occupy. The psychological impact of such a discovery cannot be underestimated. For centuries, humanity has gazed at the stars and wondered what might drift through the gulf between systems. The answers came slowly, with the detection of Oumuamua and Borisov. But this is something larger, stranger, and far more dramatic. It reminds us that the universe is not a static backdrop, but a living theater where immense objects traverse unimaginable distances, intersecting our lives in fleeting moments that carry the weight of galactic history. The solar system, once thought to be a relatively isolated arena, is revealed as porous, open to the ceaseless traffic of the galaxy. As speculation about the object's mass and composition intensifies, some researchers point to its reflective irregularities as evidence of an unusual surface structure. Perhaps it is riddled with metallic veins, the remnants of differentiation processes in a lost planetary crust. Others suggest its luster may come from exposed crystalline ice hardened under cosmic radiation, preserved over untold millennia. If either is true, then its analysis could unlock knowledge about environments utterly unlike our own. Even a single shard of information gleaned from its surface could reshape our understanding of how matter organizes itself under alien conditions. The dance between this colossal body and 3I-ATLAS may also teach us about the gravitational subtleties at play when two interstellar travelers meet within the influence of a star. Will they brush past one another, exchanging momentum in a delicate slingshot? Will their paths diverge forever, never to meet again after this brief solar system encounter? Or could the sun's gravity choreograph them into a fleeting gravitational embrace, a temporary binary relationship played out against the canvas of interstellar void? Each scenario offers a lesson in dynamics, each possibility a window into the grand machinery of cosmic motion. The sense of anticipation is sharpened by the knowledge that this is happening now, in our time. Countless generations of humans have lived and died without ever seeing such a spectacle. And yet within a single decade, we have gone from no confirmed interstellar visitors to witnessing multiple arrivals, culminating in this gigantic object's entry. It underscores how dynamic our age of astronomy has become, where instruments sensitive enough to capture the faintest glimmers from the edge of the solar system can rewrite our place in the cosmos overnight. For philosophers and dreamers, the event ignites questions about meaning and connection. If two interstellar objects truly converge here, it suggests that the galaxy may weave narratives far richer than chance alone. It evokes the idea of cosmic journeys spanning millions of years, of objects traveling together unseen, only to reveal their kinship in the light of another star. For scientists, the emphasis is on data, composition, trajectory, and interaction. But for the broader imagination, it is about belonging, about recognizing that our solar system is not an island, but a crossroads. In the coming months, as the object draws nearer, the precision of measurements will increase, peeling back layers of uncertainty. Already, excitement surges through conference halls and research forums, as scientists debate whether to classify it as a comet, a planetoid, or a wholly new category of interstellar behemoth. The language of classification feels inadequate, straining to contain something that has no precedent. It is not just that the object is big, it is that it carries with it the possibility of rewriting the textbook definition of what interstellar wanderers can be. This convergence is a reminder that the universe holds surprises far beyond the scope of our current models. Just as Oumuamua shattered assumptions by arriving without a cometary tail, and Borisov astonished by behaving like a textbook comet from another system, this gigantic visitor has arrived to challenge our complacency yet again. It brings with it the thrill of the unknown, the prospect of discovery, and the humbling recognition that our solar system is but a stage in a far larger galactic drama. And so we watch as the giant advances, silent, relentless, unbothered by the stir it has caused on the small blue planet orbiting the sun. It moves with a dignity born of ages spent in the void, carrying with it the secrets of stars long gone cold. Ahead of it lies 3I-ATLAS, another emissary from another time, awaiting the encounter that has set astronomers and dreamers alike alight with anticipation. Whatever the outcome, the convergence of these two interstellar travelers within the bounds of our solar system marks a moment of extraordinary significance, a reminder that even in the vastness of space, paths can cross, and mysteries can deepen in ways no one could have predicted. The gigantic object that has entered our solar system has quickly become a centerpiece of fascination, its presence both a puzzle and a provocation. In the quiet reaches where only the most remote comets and trans-Neptunian objects normally drift, this massive interloper has introduced an entirely new dynamic. Astronomers and theorists alike now face the exhilarating challenge of explaining what such a body is, where it came from, and why its trajectory aligns so intriguingly with that of 3I-ATLAS. While the early discovery phase raised questions, the deepening research has opened avenues that extend well beyond astronomy, touching on cosmochemistry, galactic dynamics, and even the philosophical dimensions of humanity's place in the cosmos. From the outset, the sheer scale of the object has forced experts to reassess what kinds of materials can survive the brutal processes of interstellar ejection. Planetary systems are turbulent in their youth, scattering planetesimals outward under the gravitational influence of forming giants. But most of what is expelled tends to be relatively small, irregular fragments. To find an object that borders on being moon-sized, gliding into our system intact, suggests a remarkable resilience. It may have a dense internal structure capable of withstanding cosmic collisions, or perhaps a composition rich in metals and silicates that give it unusual durability. This opens speculation about whether the object is a rare survivor of catastrophic events in its home system, an ancient ruin of a world that never became a planet. As research unfolds, astronomers are piecing together hints about the object's motion. Interstellar objects generally arrive with hyperbolic velocities, their speeds too great to allow permanent capture by the sun's gravity. Yet the motion of this newcomer is subtly different. It is fast, yes, but its trajectory has a smoothness that defies expectations, as though it is gliding along a predetermined route rather than tumbling randomly through interstellar space. The alignment with 3I-ATLAS sharpens this sense of purpose, compelling observers to wonder whether the two bodies are bound by some shared history. Could they have once orbited the same parent star? Might they carry signatures of identical mineralogy or isotopic compositions that tie them back to a common birthplace? These are the questions that ignite laboratories across the globe as spectroscopic surveys continue. The chemical fingerprints of the object are among the most anticipated discoveries. With spectroscopy, scientists can decode the unique spectral lines emitted or absorbed by its surface materials when sunlight strikes it. Already, preliminary observations suggest a surface with unusual reflectivity. It does not behave like icy comets whose volatile gases burst forth when heated, nor like the dark, carbon-rich asteroids scattered across our solar system. Instead, its brightness varies in ways that imply crystalline structures or metallic facets. If the object turns out to be rich in metals, it could represent the exposed core of a once larger body, stripped of its outer layers during a violent collision in its system of origin. On the other hand, if it contains rare ices stabilized under cosmic radiation, it could provide a glimpse into environments utterly foreign to those we know. The relationship with 3I-ATLAS intensifies the intrigue. Interstellar objects are so rare that the statistical probability of two arriving with intersecting paths is astonishingly low. This has led to competing schools of thought. One emphasizes coincidence, arguing that in a galaxy filled with countless ejected bodies, such alignments are bound to happen eventually. The other entertains the idea of linked trajectories, that these bodies might be remnants of a larger collective ejection event. If that is the case, then our solar system could be witnessing the convergence of fragments that have traveled together across light years, only to reveal their connection under the gaze of terrestrial instruments. In either scenario, the implications are vast. Interstellar objects may not always wander alone, but may arrive in clusters, their paths influenced by common origins. The entry of a massive object like this also has practical implications for how we study cosmic visitors. Past encounters, like those with Oumuamua and Borisov, were fleeting, offering only brief windows of observation before the object sped away. The sheer size of this new arrival ensures that it will remain visible for much longer, giving humanity unprecedented time to investigate. Large telescopes can follow it for years, mapping its rotation, its light curves, and its potential for interaction with solar radiation. More tantalizing is the prospect of sending robotic missions to intercept it. The technical challenges remain immense, as such missions must achieve extraordinary velocities to close the distance. Yet the rewards of sampling material that originated outside our solar system, and perhaps in concert with 3I-ATLAS, are unparalleled. A single fragment could rewrite our understanding of planetary chemistry beyond the sun's reach. Beyond the scientific considerations, the arrival of this object has stirred deeper reflections about the interconnectedness of the galaxy. It forces us to imagine the pathways by which matter is exchanged between systems. A body launched outward from a distant star millions of years ago now drifts past our sun, bearing the imprints of forces that sculpted worlds beyond our imagination. The possibility that it carries organic compounds or prebiotic molecules adds another layer of significance. If life arises from such building blocks, then interstellar objects like this one may play a role in scattering seeds of potential across the galaxy. The notion that two such bodies may meet within our system magnifies the drama, suggesting that galactic dynamics weave more intricate patterns than we previously recognized. The gravitational stage on which this convergence may occur is also worth considering. Our sun's mass exerts influence on everything within reach, curving the paths of visitors into hyperbolic arcs. But when two interstellar objects approach one another within this field, their mutual gravity could also come into play, however briefly. A close pass between the gigantic body and 3I-ATLAS might result in subtle deflections, slight alterations to their courses that leave measurable imprints. Tracking these shifts would give astronomers rare insights into the mechanics of such encounters. The outcome could be as simple as parallel trajectories that diverge forever, or as dramatic as a gravitational slingshot that redirects one deeper into the solar system. Even in the absence of a collision, the choreography of their meeting holds a wealth of information. The cultural dimension of this discovery cannot be ignored. humanity has always responded to the heavens with awe, weaving myths, stories, and philosophies around celestial phenomena. The arrival of a gigantic interstellar object resonates with that ancient impulse, stirring questions not only of science, but of meaning. For some, it evokes wonder at the sheer scale of cosmic processes that reach into our small corner of the universe. For others, it provokes unease, a reminder that we inhabit a system that is not closed or shielded but open to incursions from the wider galaxy. In a sense, this object is both a messenger and a mirror, reflecting our own limitations while offering a glimpse into realities we had not dared to imagine. As the object's approach continues, its surface details grow clearer. Light curves suggest a slow rotation, revealing alternating facets of brightness and shadow. These may indicate ridges, craters, or irregular structures, hinting at a complex history of impacts and erosions in the harsh environment of space. Each scar may carry evidence of ancient collisions or long exposure to cosmic rays. If spacecraft one day reaches its surface, those scars would serve as a record of millions of years of interstellar wandering. For now, telescopes can only infer, but every additional dataset sharpens the picture of this colossal traveler. Scientists also wonder about the long-term fate of the object after it completes its passage through our system. Will it continue onward, unaffected to vanish once more into interstellar darkness? Or could its interaction with the Sun and with 3I-ATLAS alter its course significantly? If gravitational forces conspire just right, it could even find itself bound temporarily within the outer solar system, a rare capture of interstellar matter. While such a scenario remains unlikely, the mere possibility adds excitement, for it would provide centuries rather than years to study the object directly. Even a temporary capture could revolutionize our understanding of how interstellar material is assimilated into planetary systems. At the theoretical level, the presence of such a large interstellar visitor forces revisions to models of galactic transport. Simulations of planetary system evolution must now account for the survival and ejection of bodies of this magnitude. Astrophysicists are already running high-resolution models to explore how gas giants, binary stars, or stellar migrations might catapult such large fragments into interstellar space without destroying them. The answers will not only explain this object, but also refine our understanding of how planetary systems, including our own, shed material over cosmic time. In the broader context of cosmic exploration, this event reminds us that we live in an age of discovery, where boundaries between speculation and observation blur rapidly. A decade ago, interstellar objects were theoretical curiosities. Then came Oumuamua, challenging assumptions with its enigmatic shape and behavior. Borisov followed, behaving like a familiar comet but from an alien birthplace. 3I-ATLAS arrived next, adding another chapter. Now this gigantic object takes the story further, stretching the boundaries of what interstellar visitors can be. Each arrival has been larger, stranger, and more consequential than the last, as though the universe is steadily revealing layers of complexity in a sequence timed for our observational readiness. The convergence of this gigantic body with 3I-ATLAS has set in motion one of the most ambitious observational campaigns ever attempted for a transient cosmic event. International collaborations coordinate nightly observations, pooling data from observatories across continents. Amateur astronomers contribute as well, their smaller instruments adding breadth to the coverage. The combined effort is unprecedented, transforming this single object into a global project of shared discovery. In many ways, it echoes humanity's first steps in collaborative space exploration, reminding us that the pursuit of knowledge is both a scientific and a collective endeavor. Even the possibility of future interstellar objects arriving in families or clusters changes our outlook on the galaxy. It suggests that our solar system might not just occasionally host a lone wanderer, but could at times witness processions of bodies linked by origin. If this is confirmed, it will reshape how we search for and track these visitors. Astronomers may one day map the flows of interstellar debris across the Milky Way, tracing invisible rivers of matter that stream between the stars. This gigantic visitor may be the first tangible sign of such cosmic currents, revealing that our galaxy is alive with exchanges more dynamic than we imagined. The thought that two objects from another star system are converging here, within reach of our instruments, underscores how much remains unknown. Each new discovery pushes the horizon of our understanding further outward, leaving us humbled by the enormity of the universe's mysteries. Yet it also invigorates us, for it proves that the cosmos is not a static tableau, but a dynamic realm filled with encounters that defy prediction. The gigantic object now gliding toward 3I-ATLAS is a testament to that dynamism, an event that will echo in the annals of astronomy as one of the most extraordinary alignments ever recorded. The gigantic object advancing into our solar system has already transformed the field of planetary science, but the conversation it sparks goes far beyond cataloging another interstellar visitor. Its very presence forces us to re-examine what we thought we understood about the architecture of the Milky Way, the stability of planetary systems, and the ways in which cosmic debris migrates over unimaginable distances. While telescopes refine its path and laboratories prepare for compositional studies, theoreticians are already exploring scenarios that reach into the deepest mechanics of galactic life. One of the most pressing questions concerns how such a massive object managed to leave its home system at all. Smaller planetesimals can be ejected relatively easily, flung outward by gravitational interactions with gas giants or stellar companions. But the larger a body becomes, the more gravitationally sticky it is, the harder it is to dislodge. For a giant fragment to be launched into interstellar space, something extraordinary must have happened. Perhaps the parent star of this body underwent dramatic changes, an unstable binary interaction, a passing encounter with another star, or even the slow dance of migration within a crowded stellar nursery. In each scenario, the forces would be immense, enough to fling whole worlds away from their stars, turning them into drifters in the cosmic void. The presence of this object within our solar system hints at violent dramas playing out far away, events we can only piece together by studying these silent survivors. The idea that such objects may carry traces of their lost homes electrifies researchers. Within its mineral structures may lie isotopic ratios unique to the chemistry of its parent star system. If such markers are detected, it would give us a fingerprint, a way to tie this body back to its origins across the galaxy. Imagine being able to say not only that an object came from interstellar space, but also from a specific type of star system. Perhaps one rich in heavy elements, or one poor in volatiles. Such insights would expand astrophysics beyond observation of distant light, offering tangible samples of alien systems in our very backyard. Even before any sample return missions are considered, telescopic observations can probe the giant's mysteries. Infrared studies, for example, can reveal the thermal properties of its surface, determining whether it is covered in insulating regolith or bare rock. Polarimetric measurements, which analyze the way light scatters off the surface, can expose textures and particle sizes. Together, these techniques can begin to outline a story of weathering, radiation exposure, and micrometeorite impacts endured during eons of interstellar travel. The narrative etched on its surface may be one of resilience in an environment harsher than any within the shelter of a solar system. The gravitational interactions between the gigantic object and 3I-ATLAS also open doors to a new branch of research. Astronomers are keen to calculate exactly how close the two bodies will come to each other. Even small gravitational exchanges could shift their trajectories, creating measurable differences that ground-based instruments can detect. This would provide a rare chance to study the physics of interstellar objects not just in isolation, but in mutual relation. If by chance the two pass at a proximity sufficient to tug at one another, it could even alter the course of one or both, sending them on new journeys that extend beyond what our current predictions suggest. Observing such an event would be like watching the choreography of celestial wanderers on a galactic stage, their movements governed by laws of physics that play out in real time. The timing of this arrival is itself remarkable. Humanity's observational capacities have never been greater. With wide-field surveys constantly scanning the skies, sensitive detectors capturing faint photons, and artificial intelligence accelerating data processing, we are equipped to detect objects that previous generations would have missed entirely. The discovery of the gigantic interstellar body is not only a testament to cosmic chance, but also to the technological maturity of our species. We are finally able to watch the galaxy send us emissaries, able to catch them before they slip away unseen. This moment underscores the profound link between human progress and cosmic revelation. The universe reveals itself when we are ready to notice. Speculation abounds regarding whether the object carries volatile compounds, and if so, What kind? Interstellar travel exposes such bodies to intense radiation fields, which can strip or transform surface molecules. Yet the deep interiors of such an object may preserve pristine material, shielded from the worst of cosmic rays. If ice or organic compounds lie buried within, their discovery could change our view of chemical evolution across the galaxy. Organic molecules detected on comets within our solar system already hint at the universality of life's ingredients. To find similar or even more complex chemistry on an interstellar giant would reinforce the idea that the seeds of biology are strewn widely across space, waiting for environments like Earth to nurture them into something more. The psychological impact of such a visitor cannot be understated. Humanity has long grappled with the question of whether we are alone in the cosmos. While this object does not directly answer that, it represents a bridge between systems, a reminder that the universe is not compartmentalized, but deeply interconnected. To know that a massive body formed around another star and now passes near ours brings home the idea that we share the galaxy in tangible, physical ways. It collapses distance in the imagination, turning abstract light years into something immediate, something present in our skies. There are also debates about terminology. Should this body be classified in the same way as Oumuamua, Borisov, or 3I-ATLAS? Its immense size sets it apart. Some scientists argue that a new category may be necessary, perhaps interstellar planetoid or galactic fragment. Classification is not just semantics. It shapes how research is conducted, how funding is allocated, and how missions are proposed. By naming it correctly, we align our efforts with its true nature, acknowledging that it challenges the boundaries of our current frameworks. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on this gigantic object entering our solar system? We want to hear from you. Thank you for watching and see you next time.